Hi everyone, welcome to my YouTube tutorial. In this tutorial, I'm just going to continue with the previous video on the sulfonation of alcohols. So in this chapter, I'm just going to do a bunch of examples how we can use the sulfonated alcohol to manufacture or to synthesize new groups, new compounds with different functional groups. So therefore, if I have this type of group that I want to incorporate it in a given structure, and I have this type of sulfonated alcohol. So if this is my sulfonated alcohol and this is what I want to incorporate in, so the mechanism is going to be that this oxygen with the lone pair will attack this carbon. We'll do what we call a backside attack. So when that happens, this bond will break off, then we shall form our new product that looks like this. So this is our new product. So if I have something like let me use cyanide itself. If I use cyanide with the same sulfonated alcohol, so I will still have the same mechanism. This carbon, which is the carbanion, will attack this carbon, backside attack. This breaks off. Then we form a CH3, CH2, C double bond to the N. So you see how I've included this functional group. I've elongated, and now I have 3 carbons. And this one I've incorporated this new structure in. So this is how these sulfonated compounds are so important, because we can use them to synthesize other functional groups or elongate a chain. So they are very important during what we call synthesis routes. So so what type of questions can they ask in this form of sulfonation of alcohols? So take an example. If they give you a structure like this, if they say so they can say you have this as your starting group, and they said this this compound first was phosphorylated in presence of pyridine, and then it was passed under a sulfonated compound, sulfonation. So if I may represent it like this, let me say sulfonyl chloride. Oh, this, then okay. Initially it was this, then first, then second, I pass this through I pass this through a CH3 or group, a methoxy group. Okay, so if I have something like this, they will say if my beginning compound is an ara group, if I may say, so what will be the end product, and what stereoisomer or what enantiomer will it be having? So what you have to look up is that when you react an alcohol with this phosphorus trichloride, we are going to have what we call a backside attack. So a backside attack is when, the first product we shall have will be the same enantiomer as this, because we don't have a backside attack. Remember, this OH will attack this phosphorus, and we form our product as CH3, then O to the Pl2, then this will be our hydrogen. So this will be our first product that we shall form. Then remember, we will have a chloride ion that will come to replace this, So this is when the backside attack comes in. So when this chloride ion comes to attack this carbon from the opposite side, so we shall have this compound will have an opposite enantiomer as this on the next step. So in the next step, when this chloride ion comes in to bond with that, we shall have a different enantiomer. So therefore, this will be the hydrogen, then the chlorine will come in. So now, if this is R, this will still be R, but this will be S because of this backside attack. Or you can say there's a process called inversion. So inversion occurs at this point. So then if I react, so this is my first part. So now if I react this compound with this other nucleophile, so what is going to happen is that we are going to have a second inversion or a second backside attack. So this nucleophile is going to attack this carbon from the opposite side, hence breaking off this. So we shall have our final product as so this will be our final product. So now you see how I've regained back my R. So my final enantiomer will have the same configuration as my first, because here in the first mechanism I did not have any backside attack or evasion, so my configuration remained the same. In my second reaction, when this chloride atom attacks this structure, it will attack it from the side, backside attack or evasion. Then the configuration will change to S. Then when I bring in this nucleophile, it is going to attack this carbon from the back, so which is our second evasion. Then we shall go back to our configuration as we began with. So these are some of the questions they can bring for you as far as enantiomers with these electrophilic substitution reactions are concerned. So thank you very much for watching. Catch you in my next tutorial as we discuss more and more functional groups in organic chemistry. Bye for now.